what we covered up in the last class, finding the great circle distance using the cosine formula. So we made this PAB triangle, and in this PAB triangle we applied the cosine formula to angle P, and once you apply that you get distance AB. Side AB is obtained, converted into minutes, that gives us the great circle distance. So up to here everybody okay beta? Can we proceed ahead now to finding the courses?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Very good beta, great. So we are moving ahead now, and we are now going to find out the courses, initial and final course. Let's go. Now, having found the great circle distance between our starting and destination position, we come to the second part of the question now. The second part requires us to find out the initial and final courses. Now, to find the initial and final courses, we need to calculate angle A and angle B of the spherical triangle PAB. So we have this PAB triangle, a spherical triangle. We have already found the missing side, the unknown side of this particular triangle, that was side AB. Two sides were already known to us, Papa Alpha, which is the colat of A, Papa Bravo, which is the colat of destination position B, and the third side has been found in our previous calculation, that is side AB, which is the great circle track or the great circle distance between our initial and final position. With all the three sides known to us now, again we can use the cosine formula to find any angle of this triangle. So we will use this formula to find out angle A and angle B of our spherical triangle. So let's apply the cosine formula to angle A. Cos of angle A is equal to cos of PB. You see PB is the opposite side to angle A, minus cos of PA. PA is the adjacent side to angle A, into cos of AB. AB is the adjacent side again to angle A, whole divided by sine of PA into sine of AB. So you see we have applied the cosine formula once again, this time to angle A, and you can see in this formula all the items on the right hand side which are marked in green are already known to us. We know PB, we know PA, and we know AB also. Again, reminder to you, the AB side which we are going to use here will be the value of AB in degrees and minutes. We converted into whole minutes to find out the great circle distance, but whenever we use side AB for any calculations, we do not use the minutes format, we use the degree minute format. So once the formula is applied, the angle A can be easily obtained. So once angle A is obtained, we move on to angle B now. Angle B is similarly calculated by applying the cosine formula again. Let's apply the cosine formula for angle B. Cosine formula will now say cos of B is equal to cos of PA. You can see PA is the opposite side to angle B, minus cos of PB. PB is the adjacent side, multiplied by cos of AB. AB is the second adjacent side to angle B, whole divided by sine of PB into sine of AB. Again, you can see all the items on the right hand side marked in green are known to us. The only unknown here in this equation is angle B. So putting all these values in the equation, we can easily calculate the angle B value. It's a single step calculation in the scientific calculator. So remember these formulas. They are simple applications of the cosine formula. If you know the cosine formula, you don't need to memorize them. It is just a application to whichever angle we require. So once the cosine formula is applied here in this way, both these angles, angle A and angle B, are known to us. Now, how do we obtain the initial and final courses from these two angles? Let's. Okay, beta, before we proceed ahead, up to here, any doubt in your mind?
No, sir.
No
No,
doubt.
sir. Uh, Sir, how you measure the angle, sir? If angle A or angle B?
You are asking how do we measure the angle?
Yes, sir.
We don't need to measure the angle, beta. We just need to put these values in the calculator and get the answer. That's all.
Okay.
The calculator will straight away give us the answer in degrees and minutes. So you just pick up that value, write it down. That's all. You don't need to measure it.
Okay, sir. Thank you.
Okay. All right. So shall we move ahead, beta?
Yes, sir.
Yes,
Very
sir.
good.
Yes, sir.
Let's go. See. Now the first important thing to understand here is that just now what we have found are the angles of the spherical triangle PAB, angle A and angle B. Now these are not our initial and final courses, but these angles are going to help us find what our initial and final course will be. In some cases, you will see numerically angle could be equal to the initial or final course, but in another case, they could be different also. So always remember, this should be clear in the mind that what we have found using the cosine formula are the angles of the triangle, and we need to use these angles to find out our initial and final courses. Now the method which we are going to use here gives us the courses in 3-figure notation or 360-degree notation or true notation. We also use quadrantal notation for denoting the courses, but with this technique we are not going to get the courses in the quadrantal notation. We will get them in 3-figure notation. Now the course of the ship in 3-figure notation is basically the angle between true north and the ship's head measured clockwise. The angle is measured with reference to true north. We measure the angle in the clockwise direction and we measure it up to the ship's head. This is the definition of the course in 3-figure notation. The angle is measured from 000 to 360 in the clockwise direction. So let us now see how these angles, angle A and angle B, are going to give us the initial and final courses. So for this, we need to make a rough diagram of the ship at our starting position A and the destination position B. So a rough diagram of the ship at both these locations. Let me make the PAB triangle here also. We don't need to show the full earth diagram now. We can now concentrate only on the PAB triangle part of it. So you see the North Pole, you see the initial position A, and you see the final position B. AB is the great circle track between these two positions. Let's first make a rough diagram of the ship at position A when it is moving on this great circle track, and let's make the rough diagram of the ship at our destination position B. Beta, any doubt up to here?
Yes, sir. If you're drawing something, sir, I cannot see it. The screen is frozen. I can only hear you.
Okay. Beta, what about other candidates, Beta? Can you see the screen?
Yes, sir.
Yes, sir. Well and clear.
Everything is clear.
Right, Beta. So that's some net speed issue at your end, Beta. If it is still frozen, you can log out and log in again.
Okay, sir. I'll do that.
Okay. Okay, Beta. All right.
Okay, sir.
Okay. So shall we move ahead?
Yes, sir.
Yes, sir.
Okay. All right. Ajay, can you see the screen now, Beta?
Yes, sir. Now I can see.
Very good, Beta.
Okay.
Great. So let's proceed ahead. So we have the rough diagram at both these locations visible now. Now for finding the initial and final courses, follow a simple 1, 2, 3 stepwise procedure. Follow this 1, 2, 3 method and measure the course as an angle. What is this 1, 2, 3 method? Number 1, identify and start from north. Let's go to our initial position A. Now at this position, which is the northerly direction? That is the first thing which we need to identify. We are aware, we know that the meridian run in north-south direction. Towards the North Pole, the direction of the meridian gives us north direction, and towards the South Pole, the meridian shows us the 180 or southerly direction. So to identify the north direction, we basically have to see where is the meridian going. Now when the ship is at point A, the meridian is this green color track, which is taking us to the North Pole. So let's mark it as point N. So this N represents the direction of the true north. Similarly, when the ship is at its destination position B, again we have to identify the north direction. So let's identify the meridian. The direction, the meridian is represented by this blue color track going to the North Pole. So this is where the north direction is. Let's again mark it with the N, showing that, representing that this is the northerly direction. So this is step number 1. Identify and start from north. Now moving on to step number 2. We have to go clockwise from here, that is from the north direction. We have to go clockwise, and in step number 3 we have to go up to the ship's head. So starting from north, let's come to our initial position A first. Starting from north, I move in the clockwise direction represented by this light blue color arrow. So starting from north, going clockwise, I go up to the ship's head. Now this angle basically gives me my initial course. Following this procedure at the destination position also, starting from north, going clockwise, I go up to the ship's head. So this is marked by this light blue color arc and arrow. So again we followed the 1, 2, 3 procedure. One is identify north, two is go clockwise, three is go up to the ship's head. So this arc which we see here gives us the final course. Now you can see here in this diagram that our initial course is equal to angle A of the PAB triangle. So fortunately in this case, whatever angle A we obtained by using the cosine formula, same angle converted into three-figure notation gives us the initial course of the ship on the great circle track from A to B. Now let's go to the destination position. Now at destination position, this is not the case. The angle B which we have obtained using the cosine formula is the inner angle of the triangle PAB. Inner angle. But our course is not the inner angle of the triangle. Our course in this case is the outer angle B of the triangle. So you can see here that the angle B calculated using the cosine formula will be a different value, whereas the final course of the ship at the destination position will be a different value. We can use the angle B to find out our final course. How can we do that? Now, just as a straight line, if you pick up any point on a straight line and you measure the angle of that straight line, it will always come to 180 degrees. 180 degrees is also known as a straight angle. So at any point of a line, if you measure the angle, it will be 180 degrees. Now this stands true in case of a great circle track also. So if you are at point B and you measure the angle from direction of A up to the direction in which the ship is heading, this total angle will be 180 degrees. This total angle being 180 degrees, we know the inner angle B. So 180 minus the inner angle B gives us the outer angle B. The outer angle B is what we require. Outer angle B is our final course. So 180 minus the angle B calculated using cosine formula gives us the final course of the ship. So beta, have a good look up to here and let me know any doubts you are having up to this point.
Sir.
Sir, we have to copy down all this.
No beta, not required. You need to understand it. Okay, you need to understand it, and once it is understood, you can apply it in the questions. Okay, so shall we move ahead, beta?
So, yes, sir. We can move ahead.
Okay, all right. Another confusion which can come to your mind is that this great circle track from A to B appears as curved. So if you measure the angle at any location, on the convex side it should be greater than 180 and on the other side it should be less than 180. But that is not the case. The angle in both these cases will be exactly 180 only. The curvature is just to represent that this triangle is formed on a curved surface, on a 3D surface, the surface of a sphere. So that is what the curvature denotes. The angle will still be 180 degrees measured at any point on the great circle track. So as we have seen here, Fortunately, angle A and the initial course both are having the same value, but in case of our final course, the angle B and the final course are not of the same value. Angle B has helped us to calculate the final course of the ship.
Sir, how we'll write the in a quadrantal form, sir? This initial course and final course.
Okay, so beta, by using this method, you will get the course in the three-figure notation. Now, once you have the course in three-figure notation, we know how to convert a three-figure notation to quadrantal notation. So that's a 10-second job for us. So obtain them in three-figure and then convert them to quadrantal if you require. Okay, beta, got it?
Yes, sir. Yes, sir.
Okay. Don't try to get the quadrantal course directly from the diagram. That may be confusing at some times. Okay. So from the diagram, you get it in three-figure notation, and once you have it, then you can easily convert it to quadrantal notation if you like. Okay. So shall we move ahead, beta? Shall I show you one more example?
Yes, sir.
Okay, beta. Just a minute. Now let's take an example of the ship moving on a westerly course. The procedure is slightly different here. So in our initial example, we had considered a ship moving in the easterly direction in the northern hemisphere. Now let's consider a ship which is moving on a westerly course and see how does this process helps us to find out the initial and final courses. Let's make a rough diagram first. You can see the pole here at point P. Our initial position is at A. You can see point A here, and the final position is at Bravo. You can see the point B on the screen now. So let's make the PAB triangle. We have the blue color side, the Papa Alpha side. We have the second side, Papa Bravo side of our spherical triangle PAB. And you can now see the third side representing the great circle track between A and B. The arrow shows the direction of the track. Vessel is moving from A to B. So with the rough diagram now made, showing the starting position, the destination position and the pole, let's now follow our stepwise procedure. Step 1 says we have to draw the rough diagram of the ship on the starting position as well as the final position. So you can see a rough diagram of the ship being made at A. Let's make the rough diagram of the ship at point B also. Now we are going to follow the 1, 2, 3 method. Step 1 is to identify and start from north. So as discussed earlier, the direction of the meridian going towards the North Pole gives us the northerly direction at any particular point. So at A, the direction of the meridian going towards the North Pole gives us the northerly direction. So let's mark it as N. And at point B, the direction of the meridian going towards the North Pole gives us the northerly direction here. Now the second step is, from this northerly direction we go clockwise and we go up to the ship's head. So at our position A, starting from the northerly direction, moving in the clockwise direction, I go up to my ship's head. So this light blue color arc and arrow shows us the initial course of the ship. Now from the cosine formula, we are able to find out the internal angle of this triangle, that is this angle A. But for the course, for the initial course, the angle which we need to find is this complete outer angle. So how do we find this outer angle from here? The total angle starting from north, going clockwise and coming back to north is 360 degrees. Just as it is with straight lines, you start measuring the angle at any point on the straight line, going clockwise, coming back to that line, it gives you 360-degree angle. So this complete angle starting from N, going clockwise up to N is 360 degrees. The internal angle A is known to us. So our initial course in this case will be 360 minus angle A. So you can see it here. The initial course in this case is going to be 360 minus A. Let's come to the destination position now. We have identified the northerly direction. Let's go clockwise from the northerly direction and go up to the ship's head. So this light blue arc and arrow gives us the final course of the ship. Now again, looking at this diagram, what we know from the cosine formula is this internal angle B. What we now require for our final course is the angle represented by the light blue arc going up to the ship's head. So how do we find it? Now for this, the first thing to understand is that just like straight lines, when two great circles intersect on the surface of a sphere, the opposite angles are the same. So if this internal angle Bravo, which was found using the cosine formula, is known to us, we know that its opposite angle, that is this one, will also be of exactly same value. So this opposite angle is equal to angle B, and we also know that from the north direction to the south direction, that means up to here, meridian to meridian, this is a straight angle, that is 180 degrees angle. So this now tells us that our final course is going to be 180 plus angle B. So you can see here the final course will be 180 degrees plus angle B. So you can see now how knowing the initial and final angles, angle A and angle B, helps us to calculate the initial and final courses. You can also find it in a different way. You can consider it in a different way. The inner angle B is known to us. From the great circle track, that is from the ship's stern up to the ship's head, is 180 degrees. So again, if you follow this method, the final course comes to 180 plus B. Okay, so now you can have a good look at the diagram and you can ask me your doubts better.
Sir, I was disconnected for last 2 minutes. Can you explain one more time regarding this B?
Yeah.
Okay, beta. Okay, no issues. I'll explain it again. See, with the cosine formula, we were able to get the inner angle B of the PAB triangle. Inner angle B. Now the course of the ship is this sky blue color angle shown the sky blue color arc which is shown and the arrowhead starting from north going clockwise going up to the ship's head. So this is what we require. What we have found out is the inner angle B. So you see from the stern of the ship up to the head of the ship is going to be 180 degrees. If you add this 180 to our angle B, you get the final course of the ship. So were you able to understand that better?
Inner angle.
Understand, sir.
What's
Go
the-
ahead.
So this inner angle is the at B is inner angle, right? Angle P BA, correct, sir?
That's right, beta. Papa Bravo Alpha PBA. This is the angle which you will get by cosine formula.
Okay. But initially, what we will have in the question is the angle at A, right? The outer angle 360 minus the outer angle at angle A. This will be the given in question.
No, beta. No, the question will give you the position of both these points A and B, latitude and longitude. That is what the question will give you. So first you will have to make the diagram and find the great circle distance, that is side AB of the triangle.
Just everything we need to find, right?
Right.
Okay,
Once you
sir.
find side AB, then you again apply the cosine formula and you get angle A and angle B, both inner angle of the triangle. Papa Alpha Bravo triangle, Papa Alpha Bravo angle and Papa Bravo Alpha angle. So
Alpha.
from
Okay, sir.
from these two angles, once you apply the 1, 2, 3 method, you will get the courses. Right, beta? Understood?
Yes, sir.
Very good, beta. So
In
if you're,
South Pole, it will be just opposite to this.
I will show you example with South Pole. Let's see that example.
Okay, sir.
Okay, shall we move ahead, beta?
Yes, sir.
Yes, sir. Yes, sir.
Very good, beta. Let's go. In this case, none of the angles was equal to the course. So we had to use the diagram and the 1, 2, 3 method to find out what is our initial and final course. Now we have seen the courses being found in the northern hemisphere with a ship moving in the easterly direction in one case and moving in the westerly direction in the second case. Now let's try to see this and let's try to see how does the method work when the ship is in southern hemisphere. In the southern hemisphere, let's consider a westerly course and try to make it as complicated as possible. So let's first make a rough diagram of the PAB triangle and then the diagram of the ship at the initial and final positions. So in this case we are in the southern hemisphere, so I take the south pole at point P here. Our starting position is at A and the destination position is at B. The meridian of A is drawn now. Papa Alpha PA, you can see the blue color line. The meridian of point B is also drawn, and let's now join point A and B with the great circle track. So in red color you see the great circle track from A to B. The direction of the arrow shows the direction in which the ship will be proceeding. So we have to first make a rough diagram of the ship at our starting position A. We have it on the screen now, and we have to make the rough diagram at our destination position B. This is how the ship will be proceeding on the great circle track. Now we will first calculate angle A and angle B. That is these angles of the triangle PAB, angle A and angle B, using the cosine formula and once these angles are known, we can use these angles to find out our initial and final courses. So let's now apply our 1, 2, 3 method and see how we can identify the course at each location. So first of all, we have to identify and start from north. The direction of the meridian going towards the North Pole gives us the northerly direction. So at point A, meridian going in this direction towards the North Pole gives us the northerly direction. I have marked it with the N point here representing true north. And if you come to the destination location, the direction of the meridian going towards the North Pole represents the true north. So true north represented by N at both the locations.
Sir, can you explain
Now
this?
we have
I
to
did
go
not get it.
clockwise. Go ahead, beta.
Yes, sir. This identification start of north. For northern courses, I understood. But for southern courses, how did you identify which is going towards north? Can you explain one more time?
Beta, you are saying for southern courses you are not able to understand.
Yes, sir. That's right. For north, it was easy to understand because the north pole is up, and north you can determine. But for southerly courses, how can we determine the north?
Basically, you are saying for southern hemisphere, how will you find it out?
Yes, sir. That's right. Yeah, for southern.
Right, that's what we are doing, beta. We are going to find this out. The ship is in southern hemisphere. You have the south pole na, in the diagram.
Okay. So the first at A you marked N, at B you also mark N.
That's right. That is the first step. Identify north. The direction of the meridian going towards the North Pole gives us the northerly direction. So we have marked north. We have done step number 1. Now we will be doing number 2 and 3 to get the courses. Okay, shall I move ahead?
Yes, sir.
Okay, beta. From this direction north, and we have to go up to the ship's head. So at our starting position A, starting from the north direction, going clockwise, going up to the ship's head, represented by light blue arc and arrow. So this arc and arrow shows the ship's initial course. Now how to obtain this course from our angle A? You see, angle A is the internal angle of triangle PAB, this particular angle. We know from north direction to south direction up to here, this angle is 180 degrees. So the initial course is given by 180 up to here plus angle A. So initial course is given in this case as 180 plus A. So beta, is it clear up to here?
Yes, sir.
Very good, beta. Shall we move on to the final course?
Yes, sir.
Okay, let's go. Would you like to make any guesses? What will be the final course in this case? Any would you like?
1 minus B.
Okay, good beta. Great. Very good. Very good. Let's go. That is the initial course calculation. Let's go to the destination position now. Again, we follow the 1, 2, 3 method. Starting from true north, going clockwise, going up to the ship's head, represented by the blue, light blue color arc as well as arrow. So what we know now is the internal angle B, that is this particular angle, but we want to know the angle represented by this arc. So how do we do that? If we know the internal angle B of the PAB triangle, I know opposite angles are equal. So this tells me that the outer angle B, this one being shown on the screen, will be equal to angle B of the PAB triangle. Now once I know this angle B, the required angle for me would be 360 minus angle B. So 360 minus angle B gives me my required angle. The final course is thus given by 360 minus B. So clear beta? Are the courses clear?
Yes, sir.
Yes, sir.
Yes, sir.
Very good.
Yes, sir.
Great. Go ahead beta. Okay, all right. So the course calculation is done. Let's proceed ahead.
Vertex. Vertex now.
So we have done these calculations, the courses calculation in the northern hemisphere as well as in the southern hemisphere, with the ship moving in a easterly direction as well as in a westerly direction. Now always remember that this method gives us the courses in the three-figure notation or true notation. If by any chance you need to find the courses in quadrantal notation, the method will not straight away give it to you. You first calculate the courses in the three-figure notation and then convert it into quadrantal notation. We are very familiar with the process of converting true to quadrantal or quadrantal to true. So that's hardly half a minute job for us. So first you calculate the courses using three-figure notation using this 1, 2, 3 method. And once three-figure notation courses are obtained, they can be converted to quadrantal if required by the paper setter. So any doubts beta up to here?
So can we do the fourth also, because fourth combination is remaining. We did the northern hemisphere easterly course, northern hemisphere westerly course. Now we did the southern hemisphere westerly course. So can we might as well do southern hemisphere easterly course so that you know.
Okay, no issues beta. Since you have done all these, you try it on the easterly course. Okay, or let me do it. Just a minute. I'll open up the whiteboard and show you. Okay, before I go into the whiteboard, let me first give you a recap of what we did. So after this, we will do the example. So let me give you a recap. Before proceeding further, let's have a recap of the steps which we discussed in solving a great circle sailing question. Now the first step involves plotting the destination position Bravo with respect to the initial position or the departure position alpha. This will be based on the difference of latitude and the difference of longitude from the initial position to the final position. So you need to be very careful, you need to be clear about the concept of how to get the D lat between two positions and how to get the D long between two positions. The name of the D lat and the name of the D long will give you an idea about the location of your final position with respect to the initial position A. Now locating the final position is very important, because if the triangle is not made in the correct orientation, the answers which you will be getting will be wrong. So the correct orientation is a must. So you please be clear about how to calculate the d lat and how to calculate the d long between any two positions. Now once B is plotted with respect to A, we have to select the appropriate pole of our triangle. Now how do we select the pole? If both the positions are in the same hemisphere, north hemisphere or south hemisphere, then whichever hemisphere the positions are, the pole which is selected is also of the same hemisphere. If both our positions are in the north hemisphere, we will be picking up the north pole for our PAB triangle. Now in case the positions are not in the same hemisphere, you are going from one hemisphere to another. In that case, whichever hemisphere has the higher latitude out of the initial and final position, whichever hemisphere has the higher latitude, that pole is used for making the PAB triangle. Now, in case the initial and final latitude is exactly same, both are having exactly same value, in that case, any pole of your choice can be taken. Let's say, for example, you started from 20° north and you are going up to 20° south. Both the latitudes are exactly same. You can pick up a pole of your choice. Now, most of the candidates are comfortable with picking up the north pole. That gives you a better looking triangle. So you can pick up the north pole in that case and solve the PAB triangle. Now once the pole is selected, A and B are plotted correctly, the PAB spherical triangle can now be drawn.
So
Once you draw the PAB spherical triangle, you have to apply the cosine formula. When we apply the cosine formula, the first thing which we obtain is the great circle distance between the two positions. And once the distance is obtained, a second application of the cosine formula gives us the initial course, and a third application gives us the final course, which can be calculated by obtaining angle A and angle B of our PAB triangle. Go ahead, beta. Go ahead.
So can you just repeat that part when you said when both the positions are in different hemispheres?
Okay. Beta, when both the positions are in different hemisphere, you select the pole which has the higher latitude. The position having the higher latitude, you pick up that particular pole to make your PAB triangle.
Okay, sir, copy that.
Okay. Any more
Hello,
doubt,
sir.
beta?
Hello.
Bolo beta. Go
Sir,
ahead, beta.
regarding that, when this should be a different latitude, you mean like north and south? That time you need to select the higher latitude.
The pole of the higher latitude. Pole on the side of the higher latitude is used for making the PAB triangle.
Okay, okay, sir.
Okay.
And sir, can you clear the first step again, sir? The first one, plot the destination.
Beta, can you see my screen?
Sir, only yes. Now we can see. Now can see.
Okay. Can you see it now? Right. So
Yes,
let
sir.
us assume that our starting position is 10 north and 30 east and our destination position is 20 north and 5 east. अब हमें इसकी PAB triangle बनानी है, तो सबसे पहले तो मुझे ये बताओ कि बेटा पोल कौन सा लेंगे, नॉर्थ या साउथ?
North Pole.
North Pole.
वेरी गुड. दोनों पोजीशन नॉर्थ हेमिस्फीयर में हैं, सो वी पिक अप द नॉर्थ पोल. सो मैंने ये नॉर्थ पोल यहाँ पे बना दिया. लेट अस से दिस इज वेयर माय नॉर्थ पोल इज. लेट्स मार्क इट एज P. Okay. So now I have to make position A and position B. तो बेटा जो B position है मेरी, shall I make it to the right of A or left of A?
Left of it.
Left of A.
So you have to be careful. B has to be on this side, beta. A has to be on this side. And why is that? Our triangle would be like this. Oh, just a minute. We have to show the latitudes also. Just a minute. So A will be somewhere here and B would be somewhere here. So if you want to make the PAB triangle would be like this. This is how the ship will be moving. Now मैंने B को A के left में बनाया है. क्यों बनाया है? Because if you look at the longitude, we are going from 30 east to 5 east. That means we are moving in the.
सर बी थोड़ा ऊपर रहेगा सर. बी इज 20 नॉर्थ.
ए नीचे रहेगा, बी ऊपर रहेगा.
Sorry. My mistake, beta. You are correct. That's right. Let me correct it. Sorry, my mistake. It will be like this. A will be here. And B is going to be here. This will be the Great Circle track. This is where Bravo is. So why is B on the left side of A? Because we are moving in a westerly direction. From 30 east, we are going to 5 east. So, okay. Now, if somebody makes B on the right side of A, the question will become wrong, beta. Even if you apply the cosine formula, the courses would be wrong. Right? So this was the meaning of the first point. You have to make the triangle looking at the D lat and the D long. We have made position B higher than position A because latitude of B is 20 north, which is greater than the latitude of A, which is 10 north. So have you understood?
Yes, sir. Understood.
Yes, sir.
Very
We
good.
have to see the D long and D lat. Then we need to plot the triangle. Which direction we
Yes,
are
that's
going.
right. That's right, beta. That's right. Okay. Now, second thing you wanted was a example where we are moving in the easterly direction in the southern hemisphere, right, beta?
Yes, sir. As you said to calculate, so I did. Initial course is 180 minus A, and final course is B. So can you confirm it, right?
Very good, beta. I'm making it here. Let's see.
Yeah.
I have also calculated. It is same what he's saying.
Okay, great, beta. So this is our PAB triangle. We are in the southern hemisphere. This is A. Oh, sorry. This is B. This is B. And this is A. We are in the southern hemisphere moving in the easterly direction. Now cosine formula will give me this particular angle, inner angle B and inner angle A. Let us see what is our 1, 2, 3 method giving us. Let's change the color. 1, 2, 3 method says start from north. This is north here and this is north here. Start from north. Let us make the rough diagram of the ship also. This is how the ship would be at the starting position. And this is how the ship would be at the destination position. So starting from north, going clockwise, going up to the ship's head. This is my initial course. And in this case, you can see it is 180 minus A. Right, beta?
Yes, sir.
Very good. Now let us see at B. Starting from north, going clockwise, going up to the ship's head. So this is the angle which we require. And you see this is exactly opposite angle to inner angle B. So in this case, courses. Now we are advancing to problems involving the concept of vertex. Okay, vertex. So we will see what is this vertex. And then later on we will see how to use this vertex. What is the benefit of using this vertex? Vertex basically helps us to calculate any intermediate positions on the great circle track. So this is what we are going to do now. So shall I put on the presentation?
Yes, sir.
Yes, sir.
Right, beta. Let's go. The position where the great circle track reaches its highest latitude is called the vertex of that great circle. You can see the diagram of the Earth on the screen now. The North Pole is represented by point N. We have the South Pole at the bottom represented by point S. Exactly midway between them we have the equator. Now we can also see a great circle in this diagram represented by a blue color track. So this blue color great circle is there on the surface of Earth, and we can also see the plane of this great circle passes through the center of the Earth, confirming that it's a great circle. Now if you have a close look at this great circle, you will see that it reaches at its highest latitude at 2 points. You can follow the laser pointer. This is one of the points having the highest latitude. In this case, they have taken the latitude as 33 degrees north. So this is where the great circle track touches the highest latitude in the northern hemisphere. Now if you move ahead, the great circle track takes you to the southern hemisphere also, and at this particular point you reach to the maximum southerly latitude, that is 33 degrees south. This is the second vertex of this great circle. Every great circle has two vertices, one in the northern hemisphere and the other one in the southern hemisphere. So up to here clear beta?
So one moment, sir. Can I write, sir, for 30 seconds?
Yeah, go ahead beta.
Sir, just I was writing the definition, sir, for
Okay
one
beta,
moment, sir.
okay, please do, please do. Let me know when once you are done.
Yeah.
If you want, you can take a screenshot and save it. Then later on, if you want, you can make notes beta.
Okay, sir. Okay, sir. I'm done with that. Thank you.
Okay, all right. So moving ahead.
Sir, one
Bolo beta.
sir, why it is mentioned 100-degree west in this slide,
That's just a
and this is
example which they have taken. That's just a example which they have taken. Nothing else. Yeah. Okay. So moving ahead now. Now one very important property of the vertex is that at the vertex the direction of the great circle track is 090 and 270, or the direction of the great circle track at the vertex is exactly east west. The great circle track is running in the easterly westerly direction at the vertex. It is at this particular point the great circle track is closest to the nearest pole and farthest from the equator. You can have a look at the diagram. This is the vertex in the northern hemisphere, and it is at this particular point that the great circle track reaches closest to the north pole and is farthest from the equator. Now considering the equator, equator is a special great circle having no vertices. Every point on the equator is at 0-degree latitude. So when you are moving on the equator, there is no point which is having a highest latitude. Every point is at 0-degree latitude. So equator is a special great circle having no vertices. Now this property that at the vertex the direction of the great circle track is 090270 east west is very important property, and we use this property to calculate the position of the vertex. So please remember this property of the vertex going ahead. So any doubts up to here beta?
yes, sir. Sir, maybe I am understanding it wrong. So you said that this vertex will be closer to the pole. But here
Vertex is the point on the great circle track which is closest or nearest to the pole. You want to add something to it,
So
better?
you are not
So I think
audible.
it's getting
Your
confused with the.
voice
I
freezes.
think the 33-degree value is confusing
Yeah, I
because
got
that's
confused.
why
Yes,
he's.
sir.
Yeah, he got confused with 33 value. It can be any arbitrary value, so that's why he
Yeah,
confused with
yeah, that's
33.
right.
I
This
think he
is
got confused.
they.
No, if you consider it is 33-degree north also. So how can you explain it in this situation? Maybe I am understanding it wrong. So how to understand that? Is it closer to pole?
Yeah, I got confused.
Okay. Forget about beta. You can just forget about this point. This will not be required anywhere. Just let it go. Okay,
Okay,
beta.
sir.
All right.
Okay.
All right. This first point should be clear in your mind. You should always remember it that whenever you are at the vertex, or the ship reaches at the vertex, the direction of the great circle track is 090270. That means the great circle track is in east-west orientation when you are at the vertex. So just remember this. So let's proceed ahead then. Now moving further, two more important properties of the vertex. The vertices will be located with a d-long difference of longitude of 90 degrees from the positions where the great circle track cuts the equator. So you can have a look at the diagram. You can follow the laser pointer. Now it is at this particular position that the blue great circle is crossing the equator. After crossing the equator, the great circle track moves in this particular way and it reaches the vertex here. This is the highest latitude where the great circle touches. After this, the latitude starts to decrease. You can follow the laser pointer moving along the dotted line and it is going to cross the equator on the far side of the earth at this particular point. So we have two equator crossing points here. The equator crossing points would obviously be reciprocally opposite to each other. Or in other words, the d-long difference of longitude between the two equator crossing point is going to be 180 degrees. Now you can see, because of sheer symmetry of the diagram, the vertex is going to lie exactly midway between the two equator crossing points. The vertex is going to be exactly midway between the two equator crossing points. So if the equator crossing points are reciprocally opposite to each other, having a d-long of 180 degrees, it means that the vertex will be located at a d-long of 90 degrees from both these equator crossing points. This is the meaning of the first property. Vertices will be located with a d-long of 90 degrees from the positions where the great circle cuts the equator. The second property we have, the latitudes of the vertices is equal to the inclination between the plane of the equator and the plane of the great circle. Let's understand it from the diagram. We can see the equator here. The black color circle shown by the laser pointer now is the equator. We can also visualize the plane of the equator and we can also see the great circle. The great circle is represented by the blue color track. Now the plane of the equator and the plane of the great circle is having an angle of inclination or angle of cut represented by this yellow color sector. This is the angle of cut. This angle of cut is 33 degrees. Now this property says that the latitude of the vertex will also be equal to 33 degrees. In other words, latitude of the vertex is equal to the inclination between the plane of the equator and the plane of the great circle. So beta, let me know your doubts if you have any.
Sir, can you explain
Sir,
point number
can
one
you
again?
can you explain the point number one?
Okay, point number one. Okay beta. Uh, Let us assume that the great circle track is crossing the equator at Greenwich meridian. Okay, let's assume it is crossing the equator at Greenwich meridian. Now, after crossing it at Greenwich meridian, what will be the point where it will be crossing the equator again? It will be diametrically opposite to it, 180-degree meridian, right? Hello, beta, are you able to
Yes,
understand?
sir. Yes, sir.
Okay. So you can follow the cursor on the screen. If it is crossing the equator at Greenwich meridian, after increasing its latitude, going up to the vertex, moving on the other side, far side of the earth, it will be crossing the equator again at 180-degree meridian, diametrically opposite. Okay, that's because of the symmetry of the great circle and the sphere. So two equator crossing points are diametrically opposite to each other, 000 meridian and 180 meridian. Correct beta? Up to here you agree?
Yes, sir.
Right.
Yes, sir. Yes, sir.
Now also if you have a look, you will see that this vertex point, which is the highest latitude point, will fall exactly midway between the two equator crossing points. Right? Do you agree?
Sir, on that point, I have some problem of imagination, sir. It will be midway, on that point of
Exactly.
vertex, right?
That's right. It will be exactly midway between the equator crossing points. So if the vertex is exactly midway and the d long between equator crossing point is 180, so vertex has to be 90-degree d long away from the equator crossing points. Correct beta?
Yes, yes, sir. Yes.
Very good. Any more doubt beta?
Sir, with this number two, na, the second statement, can we say that this great circle, when it crosses the equator, so at that time the course when it crosses the equator will be equal to the vertex of the this great circle?
Okay. Now beta, course will not be equal to the latitude of the vertex. The angle of cut will be equal to the latitude of the vertex. So now if you are talking about the course, let us assume that the ship is at this particular location, okay, moving in the northeast direction, okay. So the angle of cut is 33 degrees. The course here would be 90 minus 33. The course will be 057 degrees when it is crossing the equator moving in the northeasterly direction. Are you able to visualize that beta?
So it will be, sir, collat of this vertex, correct?
That is right. It will be equal to the collat of the vertex.
Always, sir. Correct.
Okay.
Okay, sir.
Very good. Any more doubt beta?
No,
Great.
sir. Thank you.
Very good. Let's move ahead then. Now, when the ship is moving on the great circle track, after crossing the equator, you can follow the laser pointer. The laser pointer is exactly at the location where the great circle crosses the equator. After crossing the equator, the latitude keeps on increasing and the course of the ship keeps on continuously changing, cutting each meridian at a different angle till it reaches the vertex, which is the highest latitude point on the entire great circle. And at the vertex, the direction of the great circle track becomes 090270 or exactly east west. So we have understood what vertex is and what are the different properties of the vertex. Now, what are the use or utility of this vertex? Vertex helps us in quickly calculating the position of any intermediate point on the great circle. Now, using spherical trigonometry, we have done basic great circle problems. We have found out the great circle distance between 2 points. We have also found out the initial and final courses. But when we are doing great circle passage planning on board, we also need to find out, calculate or identify intermediate positions on the great circle track. These intermediate positions act as waypoints and helps us to plot our great circle passage on the chart. Now vertex helps us in quickly calculating the position of these intermediate positions. Now, having understood the concept of vertex and its different properties, we are now going into how to calculate or find out the position of a vertex for a particular great circle track. Now, the first thing which we need to appreciate, a very important point for getting the position of the vertex, is that there are two possibilities for the location or position of the vertex. What are these two possibilities? One of the possibility is that the vertex may lie inside the triangle PAB. PAB triangle is the spherical triangle which we made for calculating the great circle distance and the initial and final courses. Now, one of the possibility is that the vertex lies somewhere in between the position A and B. That means the great circle track reaches its highest latitude in between the position A and position B, which are our initial and final positions. Now you can see this in the diagram. We have represented the vertex by point V in the diagram, and in this particular case the vertex lies inside the triangle PAB, or the vertex lies in between our initial and final positions. Now let's try to draw the meridian of the vertex. So exactly in the same way as Papa Alpha was the meridian of point A, Papa Bravo was the meridian of point B, Papa Victor is the meridian of the vertex. Now we are aware of two things here. One, that all the meridians, they run in north-south directions. All the meridians represent north-south direction. And second, we know at the vertex the great circle track is exactly running in the east-west direction. So with the meridian running north-south and the great circle track running east-west, the angle of cut between these two has to be 90 degrees. So this tells us that the angle vector Papa Victor Alpha or Papa Victor Bravo, both these angles are going to be 90 degrees. I'll repeat once again. We know that all the meridians run in north-south direction. We know that the great circle track lies in the east-west direction at the vertex. The angle of cut between these two has to be 90 degrees between north-south and east-west. That is why angle vector of both the triangles Papa Victor Alpha and Papa Victor Bravo will also be 90 degrees. Okay, so beta, up to here, any doubt coming in your mind, please let me know.
Negative, sir.
Yeah.
Go ahead, beta.
So you're saying at the point V, the course will be a straight line, right? Then only it can cut the north-south meridian as perpendicular, right?
The direction of the great circle track is east-west when it reaches at point V or the vertex. So if a ship is moving
that
on the
will be
great
straight
circle
line,
track,
right?
it will be, if a ship is moving on the great circle track at the vertex, the heading of the ship will be either 090 or 270.
Okay, okay.
Right, beta. Next out, beta.
Excuse me, sir.
Bolo, beta.
Sir, can you go just last slide? Just I take the
Okay.
screenshot, sir. I forget to take.
हाँ, no problem, बेटा. Let me finish this. फिर मैं आपको पिछली स्लाइड भी दिखा दूंगा. Okay.
Okay, sir. Thank you, sir.
Okay, no problem. Next out, बेटा.
Sir, excuse me.
बोलो बोलो
Have you
अमित.
already explained the which side will be the vertex will be the either inside or outside because my
नहीं
connection
नहीं
got
बेटा.
lost.
I
Get
have
lost.
no. I have not explained that, beta. I will be explaining that now.
But in the figure you have already drawn the vertex inside the triangle. So
I
have you
have
already explained how it is inside drawn?
no. I have not explained it yet. I have only taken one possibility. Now I will take the second possibility. Then I'll
Okay.
explain to you when it is inside and when outside.
And which side will be either it is
I will
towards the
tell you.
angle A or
I will
towards
tell
the
you.
angle B. It is not
Yes, I will
explained, no
tell
sir.
you that.
Okay. Okay.
Not
My
explained.
connection got.
Not.
Thank you, sir.
Okay.
Sir, one more question, sir.
बोलो बेटा.
Sir, if you are saying that vertex is 90 degree,
Vertex is not
at
90
point
degrees,
B,
beta. Vertex is not 90 degree. Vertex is 90 degrees doesn't make any sense. At the vertex, the great circle track moves in the east-west direction, and the angle at vertex, Papa Victor Bravo or Papa Victor Alpha, is 90 degrees.
okay, sir. Okay.
Okay, great. So let us see the second possibility now. This is the first case. This is the first scenario where the vertex lies inside the triangle PAB or the vertex lies in between our initial and final positions. Now there could be one more scenario or one more situation. The vertex may lie outside the triangle PAB. Let me show you in the diagram. Let's assume this is the pole. A is my initial position, B is my final position. Let's make the PAB triangle. You can see the PAB triangle coming up on the screen. Now in this particular case, the highest latitude where the great circle track reaches or the position of the vertex is outside the triangle PAB. You can see the vertex coming up as V in the diagram. This is where the vertex lies in this particular situation. Let's draw the meridian of the vertex. So Papa Victor maroon color arc which you see is the meridian of the vertex, and we know that the meridian cuts the great circle at a right angle, 90-degree angle at the location of the vertex. Meridian runs north-south, great circle track runs east-west, and the angle of cut between them is 90 degrees. This is the second possibility. So depending upon our initial and final positions, there could be these two possibilities. One, the vertex lying inside the triangle PAB, and second, the vertex lying outside the triangle PAB. Now for finding the position of the vertex, we need to find out that in that given question which we are solving, whether the vertex is inside the triangle or the vertex lies outside the triangle. This is the first thing which we need to know. Now let us see how do we find out whether the vertex lies inside or the vertex lies outside. Before I move ahead, beta, these are the two possibilities for vertex. Any doubt coming to your mind?
No,
Okay,
sir.
beta. Great, very good. Now we are going to see how to find out in a question whether vertex lies inside or outside. Let's see that. So as we just now saw, we have to first check whether the vertex lies inside the triangle PAB or outside the triangle PAB. Now to check this, first of all, check the angle A and angle B of the PAB triangles. Remember, when we did the initial great circle calculation, we obtained these two angles to find out the initial and final courses. So we have to have a look at these angles. Remember to check the angles of the triangle and not the initial and final courses. So reminding you once again here that when we apply the cosine formula to the PAB triangle, we obtain the angles of the triangle, angle A and angle B. Then we convert these angles to the initial and final courses. Now to identify the vertex lying inside or outside, we need to have a look at the angles, not at the courses. If the angles of the PAB triangle are acute, if both the angles of the PAB triangle are acute, acute means less than 90 degrees, the vertex will lie inside the PAB triangle. So this is the first condition. If both the angles of the PAB triangle, angle A and angle B, are less than 90 degrees, the vertex will lie inside the PAB triangle, or the position of the vertex will be in between the initial and final positions. So is this clear up to here, beta?
Yes, sir.
Yes, sir.
Very good, beta. Great. So if both angles are acute, vertex is inside. Let us see the second scenario now. Now, in case if any one of the angles, angle A or angle B, is obtuse. Obtuse means the angle is greater than 90 degrees. The vertex will lie outside the triangle. Let me show you with a diagram. We have the PAB triangle coming up on the screen. Now, in this case, angle A is a acute angle. It is less than 90 degrees. But angle B is a obtuse angle. You can see in the diagram, angle B is a obtuse angle. In this particular case, the vertex is going to lie outside the PAB triangle. Now, when it lies outside the triangle, the next question which comes to our mind is, on which side will the vertex lie? Will it go out on the side of the obtuse angle, or will it go outside on the side of the acute angle? So always remember, the vertex will always be towards the side where the obtuse angle is. So vertex will go outside the triangle and it will go outside on the side of the obtuse angle. So in this case, the vertex will lie somewhere here. You can see the vertex coming up on the screen now. We can now show the meridian of the vertex, and we also know that angle V is a 90-degree angle. So this is the second situation. Any one of the two angles being obtuse, the vertex lies outside the triangle and it will be towards the side where the obtuse angle is. Once you know whether the vertex is inside the triangle or outside the triangle, we can now find its position easily using the Napier's rule. Any doubts up to here, beta?
No, sir.
Very good, beta. Great. So we have seen now how to find out whether the vertex is inside or outside. Once you get that, it will be very easy to calculate the position of the vertex. We are now going to see how to calculate the position of the vertex. Go ahead, Ankit.
Sir, if in some question we don't have to find the initial and final course,
Right.
then is there a way that we can find out the vertex position?
No, beta, no. For finding where the vertex is, you will have to get the initial and final angles. The angle A and angle B, you will need to calculate them. Even though the question does not require, still you will have to calculate these angles.
Okay, sir. Thank you, sir. Because
I think we can do without taking out this A and B, sir. Just we assume a position of B, and then like we'll calculate PAB triangle. Then we calculate angle P. And if angle P
Beta,
is
I would not recommend that. I would not recommend that. That becomes confusing. Okay, I would not recommend that. It is always better that when you are doing a basic great circle question, calculate angle A and B and get clarity on which side the vertex lies.
okay, sir. Copy it. But that also we can do, na, sir. The answer only.
Yes, that can be done. I will tell you that technique when we do composite sailing questions. That technique I'll tell you, but it is not to be used here. ओके यहाँ पे आपको वर्टेक्स जो है वो एंगल ए और एंगल बी को देख के ही निकालना है.
Okay, sir. Thank you.
Okay, so moving ahead now. Beta, is it okay if we move ahead, or if you want to take a break, 5-10 minutes? या अगर हम वर्टेक्स निकाल लें, नेपियर रूल कर लेते हैं बेटा, that in continuation, then we can take a break.
Yes, sir, we can continue.
Yes, sir.
Okay, beta. Great. So let me show you how we calculate the position of the vertex. Let's now see how do we find out or obtain the position of the vertex. Let's assume that in a particular situation, both angle A and angle B are acute, less than 90 degrees. And this tells us that the vertex lies inside the triangle PAB. We are just assuming this situation to look at the procedure. How do we obtain the position of the vertex? So let's make a rough diagram of the triangle PAB. You can see this triangle PAB here. Both angle A and angle B are acute angles, and we can see that the vertex lies inside the triangle. Now in this diagram we have two small right angle triangles. Karthikeya beta, can you mute your mic please? Thank you. One of them is Papa Alpha Victor, PAV. It's a right angle triangle having a right angle at the vertex. And the second triangle is Papa Bravo Victor, having a right angle at Victor. Since both of them are special spherical triangles, we can apply the Napier's rule to any one of these triangles. So let's apply the Napier rule to triangle PAV, Papa Alpha Victor. So now I'll be moving ahead and applying the Napier's rule to triangle Papa Alpha Victor. So moving on to the next slide, beta. So we have the same diagram here, Papa Alpha Bravo triangle with the vertex in between. Now if you carefully look at the triangle PAV, Papa Alpha Victor, the known parts in this triangle are the side PA, Papa Alpha. The side PA, Papa Alpha, is the colat of our initial position A. And we are also aware of angle A of this triangle. The angle A of the triangle can be easily found using the basic great circle calculation. using the cosine formula. So these two parts are known to us. So let's show them by a green tick mark. You can see a tick mark coming at papa alpha and coming at angle alpha. Now let's fill up the Napier's cartwheel for this right angled special spherical triangle. You can see the cartwheel coming up at the bottom. We have the 5 parts. Bottom 3 parts having 90 degrees minus prefix. The vertex V having 90 degree angle comes on top. Going clockwise, the next part is alpha vector. The next part is angle A, so this becomes 90 minus A. Then we have side papa alpha, so the bottom part of the cartwheel becomes 90 minus papa alpha. Next is angle P, so this part of the cartwheel becomes 90 minus P. And the next part is papa vector PV, and we come back to angle vector of the spherical triangle. Now in the cartwheel, what we know is the bottommost part, that is 90 minus papa alpha. This is known to us. And we also know the right side part, which is 90 minus A. So you can see the green color tick marks coming at both the parts. Now applying Napier's rule, we will find out the part papa vector of this triangle, or the side papa vector of this triangle. So you can see a question mark coming up on the diagram and as well as in the cartwheel. So we have papa vector part which is to be found. Now applying the Napier's rule here, the middle part is papa vector. So sine of middle part, sine of papa vector, is equal to cos of opposite part 1, which is 90 minus A, multiplied by cos of opposite part 2, which is 90 minus PA. Now both the parts on the right hand side, 90 minus A and 90 minus PA, are known to us. Using these two, we can easily find out what is the part PV, papa vector. This papa vector gives us the colat of the vertex. Exactly similar as papa alpha was the colat of position A, papa bravo was the colat of position B. Similarly, papa vector is the colat of the vertex. So PV gives us the colat of the vertex, and 90 minus PV gives us the latitude of the vertex. So latitude of the vertex has been obtained.
Sir.
So go ahead, beta.
Sir, for plotting this triangle and the vertex position, we need to calculate angle A and B firstly. Then only we can decide where the vertex lies, right?
That's right, beta.
Not only
That's right.
calculating angle A, we can proceed with it.
No, beta. You calculate both the angles, angle A and angle B. Get an idea whether the vertex is inside or outside. Then you will be able to make the triangle and apply the Napier.
Okay, sir.
Right. Next out, beta. Up to here. Okay, great. Shall we move on to the next slide?
Yes, sir.
Very good. Now let's apply Napier rule once again in this triangle. Now this time we are going to find out angle P of the triangle PAV. So you can see a question mark coming up on the diagram. The angle P in the cartwheel is the left side part. So we can see a question mark coming up here also. So the bottom 3 parts are involved in the calculation now. And out of these part, the middle part now is 90 minus PA. Other 2 parts are the adjacent parts. So applying the Napier's rule, sine of the middle part, which is 90 minus PA, is equal to tangent of adjacent part 1, which is 90 minus P, multiplied by tangent of adjacent part 2, which is 90 minus A. 90 minus PA, the left hand side, is known to us, and 90 minus A is also known to us. The only unknown here in the equation is angle P. So when we put the known parts, we are easily able to obtain what is angle P. Now if you look carefully in the diagram, this angle P is nothing but the d long difference of longitude between alpha and Victor. It is the angle at the pole contained between the meridian of alpha and the meridian of Victor, giving us the d long between alpha and Victor. Since we know the initial position of the ship, we know the longitude of position A. When we apply this d long to the longitude of A, it gives us the longitude of the vertex. So latitude and longitude of the vertex have been found out by applying the Napier's rule. Two applications of the Napier rule give us the position of the vertex. This is how the vertex position is obtained. So have a good look, beta. Let me know any doubts coming in mind.
Sir, can you explain the second part, starting from since we know initial position?
Uh,
After
okay,
angle
all right.
P is a D log between A and B, and after that, please.
That's right. Angle papa is the d long between alpha and Victor. So the initial position of the ship is given to us in the question. Position of A and position of B is known. So we have A's longitude. We know what is the d long between alpha and Victor. If you apply this d long to the longitude of A, you will get the longitude of the vertex.
Okay.
Okay. Any more doubt, beta?
So in this, can we use the same equation as sine 90 minus P is equal to tan 90 minus PV into tan 90 minus PA, as we have already find out PV?
Okay, all right, beta. So पापा वेक्टर हमने लास्ट लैटिट्यूड कैलकुलेट करने के लिए फाइंड किया था. So we know papa vector also. So can we use this papa vector to find 90 minus p? Theoretically, yes, you can use it. You will get the same answer. But practically, I would recommend not to use the part which is calculated. Okay. Why I do not recommend is, you see 90 minus a and 90 minus pa were already known to us. If you make any mistake in calculating papa vector, let us say calculation mistake is made, the latitude will obviously be wrong, but if papa vector is used for calculating longitude also, the longitude will also become wrong. So always try to prefer the parts which are known to you and avoid using the parts which are calculated by you. Okay, so that will give you slightly more accuracy. It will put you on the safe side. Theoretically, whether you use part papa vector or you use any of the two parts, it will give you the same answer using Napier rule.
Thank you, sir.
Okay, beta. Great. Any more doubt up to here, beta?
Yes, sir. I have doubts.
Bolo, beta. Go
Sorry,
ahead.
sir. Can you please explain, sir? एक बार ये longitude of vertex कैसे निकालेंगे सर?
ओके बेटा, एंगल पी निकल जाएगा. एंगल पी तक आपको समझ में आ गया कैसे निकालना है? अमित बेटा, एंगल पी निकाल लोगे?
Yes, sir. From the Napier's rule.
That's right. एंगल पी आपने निकाल लिया. This angle P is the d long between alpha and Victor.
Sir,
right?
angle तो पूरा होगा ना for the both triangle APV and the triangle BPB. That is the angle P. The whole.
No बेटा, no.
पूरा.
आपने नेपियर
Correct,
रूल
sir.
किस ट्रायंगल आपने नेपियर रूल किस ट्रायंगल पे अप्लाई किया है? आपने अप्लाई किया है पापा अल्फा
Oh,
वेक्टर
if
पे
you
बेटा.
prime triangle APV. Papa
So
alpha Victor. Okay, sir.
so it will be the
Angle
smaller
P आ
angle
जाएगा.
P बेटा. Right. This angle P is the d long between alpha and Victor. Apply it to the longitude of A, right? And you get the
Yes.
longitude of the vertex.
Yes. Yes.
Clear, beta?
Yes, sir. Yes, sir. Okay, sir. Thank you, sir.
Very good, beta. Great. So this is how we calculate the position of comes easy for finding the intermediate positions. The intermediate position problems can be broadly divided into two types. It could be asked to us in two different ways. The first type or type 1 is you are required to find the position where the great circle track crosses a given latitude. Since the latitude is given, we need to find the longitude of that particular position. So this is type 1. They will give us the initial position, the final position, and an intermediate latitude, and they will tell us to find out what is the position where the great circle track crosses that particular latitude. Now in type 2 questions, you are required to find out the position where the great circle track crosses a given longitude. Since the longitude is already given to us, we need to find out the latitude of the position. Now in both these conditions, both these types, Napier rule is used to solve. Napier rule helps us to calculate the intermediate position in both types of questions. So moving on to the next slide now, beta. We will see both these types, type 1 and type 2, one by one. Now let's try to solve a intermediate position type 1 problem. We can see a PAB triangle coming up here. The angle A and B are acute, so the vertex lies inside. So you can see the vertex in between A and B. Let's assume that our initial position is at 30 degree north latitude and the vertex latitude is 50 degrees north. So in this type of question, they asks us to find out the position where the great circle track crosses a particular latitude. Let's assume that they want us to find out a position where the great circle track crosses 40 degree north parallel of latitude. So you can see this dotted line representing 40 degree north parallel of latitude, and it crosses the great circle track at this particular location. So this is the position which we need to obtain. So let's mark off this position where the great circle track cuts the 40 degree north parallel and mark this position as X. And now let's join Papa X-ray. Papa X-ray basically denotes the meridian of position X. Exactly as Papa Alpha was the meridian of A, Papa Victor was the meridian of the vertex, Papa X-ray is the meridian of position X. Now you see the same diagram here. We have the Papa Victor X-ray triangle now. Please have a good look at Papa Victor X-ray triangle. This is a special spherical triangle, and we can now apply the Napier rule to this right angle triangle. So let's make the cartwheel. We have the parts coming up. The cartwheel is filled up. Now in this triangle, the known parts are side Papa Victor. Papa Victor is the colat of the vertex which has been obtained. So we know side Papa Victor. So let's put a green tick mark here. And the second thing which we know, the second part which we know is Papa X-ray. Since we know the latitude of position X, this parallel of latitude is given to us as 40 degrees north. We know the side Papa X-ray. So these two parts are known. Let's identify these two parts in the cartwheel also. Papa vector part and 90 minus px part are known to us. Now using the Napier's rule, we find out angle P of this triangle. So you can see a question mark coming up here at angle P. Applying the Napier's rule, you see 90 minus P becomes the middle part. Papa vector and 90 minus Px become adjacent parts. So Napier rule gives the relationship sine of middle part 90 minus P is equal to tangent adjacent part 1 tangent PV into tangent adjacent part 2 90 minus Px. Right hand side PV and Px are both known, so by putting these two values we can easily obtain the value of angle P. Once angle P is found out, if you look carefully, angle P is the d long difference of longitude between vector and X-ray. The longitude of vector or the vertex is known to us. So when we apply this angle P, d long, to the longitude of vertex, we obtain the longitude of position X. Latitude was already given to us, longitude has been obtained, so position X is found out. So beta, have a good look at the diagram application of the Napier rule. Let me know any doubts coming in.
Yes, all clear.
Very good beta, great. So let's see the type 2 problem also. Now let's see an example of the type 2 problems. In these type 2 intermediate question problems, we are required to find out the position where the great circle track crosses a particular meridian or longitude. Let's assume that our initial position A is at 30 degree east longitude, and we have also calculated the position of the vertex. So let's assume the longitude of the vertex is 50 degrees east. Now this question tells us that we need to find out the position where the great circle track crosses this particular meridian. This is 40 degree east meridian. So we have drawn this dotted line representing 40 degree east meridian, and let's assume that this particular point is X, and we have to now find out what is the position of this point X. So is the question clear, beta?
Yes, sir, clear. अभी longitude दिया है, latitude नहीं.
That's right, beta. That's right. Let's see the solution. Now we will again apply the Napier's rule, in this case to the triangle Papa Victor X-ray. So let's mark the cartwheel. Let's fill up the parts of the cartwheel. You can see the cartwheel parts are filled up. And in this triangle Papa Victor X-ray, let's identify the parts which are known to us. Now one part which is known to us is Papa Victor. Papa Victor is the colat of the vertex. The vertex latitude longitude is already calculated. So we know what is the colat of the vertex. And the second part which is known to us is angle P of this triangle. Angle P is the d long difference of longitude between the vertex and position X. You can see this is the angle at the pole contained between the meridian of vertex and the meridian of X. So we have the longitude of vertex, we have the longitude of the unknown position 40 degrees east, vertex is 50 degrees east, so we know what is the d long. So these two parts are known. Let's mark them in the cartwheel. Papa Victor is known and 90 minus P is known. Let's now try to find out the part Px. You can see a question mark coming up in the cartwheel. This is what we are trying to find out. So we apply the Napier's rule and we use the adjacent formula in this case. Sine of 90 minus P is the middle part, is equal to tangent PV, PV is adjacent part 1, multiplied by tangent 90 minus Px, which is adjacent part 2. So PV is known to us, angle P is known to us. So putting these two values, we can easily find out the side Px, Papa X-ray. Once we obtain side Px is the colat of the position x. So 90 minus Px gives us the latitude of the position x. Thus the unknown position, intermediate position, is obtained. So you see, using the concept of Napier rule and using the position of the vertex, we can easily obtain intermediate positions on the great circle track. So have a good look at the diagram and let me know any doubts coming in here, beta. Which you have to practice based on these concepts. I'll send you the solution also so you can match your working. And little later, maybe tomorrow or day after, I will be sending you one assignment. Okay, that assignment is a combined assignment for GC and composite sailing. We have not done composite yet, so you can attempt the GC sailing questions. Okay. So in that assignment, you attempt the great circle sailing question. I'll mention you which all question numbers can be attempted. So first you practice the simpler ones. Simpler ones will give you confidence, and then you do the assignment. Assignment will show you the questions which are exam level questions. Okay, so that's the plan. So that's all for today, beta. आज का session थोड़ा बिना break के हो गया.
You'll be sending solution for the assignment problems also.
I'll send, beta. I'll send you.
Okay.
Okay. So I'll send you the solutions. So आज थोड़ा बिना break के हो गया बेटा. I hope you are not feeling overwhelmed and overflow alarm is not coming.
सर जब phase 1 किया था ना उस टाइम बहुत ब्रेक ले लिए, इसीलिए दोबारा पढ़ना पड़ रहा. तो अभी सर नहीं चाहिए ब्रेक.
ओके बेटा, ऑल राइट, दैट्स ग्रेट. मैं थोड़ा डर रहा था कि बिना ब्रेक के आज हो गया. सो एनीवे, इफ यू आर कंफर्टेबल देन दैट्स ग्रेट बेटा. सो एनीवे, फ्यूचर सेशंस में आई विल accommodate a break in between. So usually I give you a break after about 1 to 1.5 hours, so that keeps the mind fresh. So next lecture onwards we'll have breaks in between. So आज का ये topic थोड़ा continuation में था, that's why it's stretched out. Okay, so great. That's all from my side for today, beta. Anything from your side?
Sir, you will be posting the questions on the group, correct? For the practice.
That's right, beta. I'll post it on the WhatsApp group.
Thank you, sir.
Sir, I'm also not added in navigation group. Sir, kindly add me in that WhatsApp group.
You are not in the WhatsApp group, beta. Just send a message to Vishnu sir. Okay.
Okay, sir, I'll do that.
Send a message to Vishnu sir. He'll add you.
Okay, sir.
Sir, actually, I have a doubt. Last class I was not able to attend. So in that, I just can I get the formula for calculating the great circle distance?
Okay. You did not attend the last session, right?
Yeah. Yes, sir.
Okay. Beta, have you seen, I had sent you a PDF on spherical trigonometry. Have you seen the cosine formula? Are you able to apply that?
Yes.
You can apply
but
that, na?
For the angle, yes, but for the side, we can apply the same formula or what? For the
I will
side.
send you. I will send you a screenshot, PPT screenshot, where the distance calculation is done. So just follow that. And if you have any doubts, next class, let me know. I'll explain that to you.
So you will be sharing this PPT also, this, sorry, PDF? Today's
No, beta.
lecture?
This is not required. This is basically application of what we had learned. So not required.